Hi, A, B, and BC calculus students. We are working on a free response question, and I just labeled it piecewise. You will not find it online. It used to be a secure document until like a year or two ago. Now it's not. Here's the thing. On secure documents, they've been putting piecewise functions for the past 3 or 4 years, and it hasn't shown up on the real AP exam. I think it's going to show up on this year's AP exam, so I want you to understand the steps that you have to do in order to not just get the question right, but to justify your answer. Okay, so let's go ahead and look at the piecewise function. F of x equals 3x squared plus 2x, and this is used when the x's are less than or equal to 0, and e to the 2x plus 2 for the x's greater than 0. Okay, now, is f continuous at x equals 0? So there's a couple formulas you want to have ready when you go to take the AP exam, and one of them is the definition of a limit. How do I know there is a limit? So the way you prove there's a limit is if the limit as x approaches some a from the left side is equal to the limit as x approaches a from the right side, then that is the limit. Okay, I should put a little f of x here for each of them. F of x, f of x. Okay, anyways, what that means, and we've talked about it before, limit, no limit, limit, no limit. So in order to have a limit, when you approach something from the left and the right, you have to be approaching the same value, and that gives you a limit. Now, a limit is not enough to prove continuity. As you can see, that has a limit and it's not continuous. What's missing is the ordered pair. If there's an ordered pair here, not continuous. If there's an ordered pair here, it's continuous. So this is the definition of a limit at x equals a. So what's the definition of continuity? Continuity. Okay. The definition is there is a limit as x approaches a of f of x. So first of all, there has to be a limit. So you first show that there's a limit, and then once you've shown there's a limit, the limit has to be at the same place as the ordered pair. The ordered pair can't be here. The ordered pair has to be where the limit is at. So it has to equal f of a. So we're going to have to show two things here for continuity. First, we're going to have to show the left-hand limit is equal to the right-hand limit, and we have to use the limit words technology. Okay, and then we're going to show the ordered pairs at the same location. All right, so let's begin. So first thing we're going to show is the limit as x approaches 0 from the left-hand side. Now if you look at these two equations, x is less than 0, that's the left-hand side, x is greater than 0, that's the right-hand side. So this is the left-hand side, this is the right-hand side. So what I'm going to do of f of x is I'm just going to go ahead and plug in. Into the left-hand side, I'm going to plug a 0 in, and I get 3 times 0 squared plus 2 times 0 equals 0. So the right-hand limit is 0, and now I need to look at the left-hand limit. Alright, and I go to plug it in here. So what's the limit as x approaches 0 from the right-hand side? And I'm looking at this, and I can't believe there's not even a limit. This is 0 here. E to the 0 is 1. 1 plus 2 is 3. Okay, so the limit as x approaches 0 does not exist. Wow. We did all this talking about continuity. And again, it's really important because you might have one that's continuous on the test. But here we had the scenario where the left-hand limit and the right-hand limit, they didn't even meet. And if the left and the right limit don't meet, it's not continuous. So if there's no limit, therefore it's also not continuous. And while that's the answer to part A, I want to show you what you would have done if they were the same. Okay, so let's pretend for a moment that these were both 3. They're not. But if they were both 3, you'd say, well, the limit as x approaches 0 of f of x is 3. And again, that would only work if that was 3 and that was 3. And then you would basically show, and what is f of 3 itself? And now we got to show what the ordered pair is. Well, what is f of 0? Which equation would you plug in to find f of 0? F of 0, the actual ordered pair, is on this one because of the equal sign. Oops. Alright, anyways, it's not drawing scale, but anyways. So, f of 0 itself you'd get by plugging into here. Now, of course, here that number is 0. Those aren't equal. But if it was going to have a limit, this would be this, and then let's just go ahead and pretend these were both 0. Okay, if they were both 0, we would say this is 0, and f of 0 we'd get here is also 0. And since those are both 0, then you could say, since the limit is equal to the ordered pair, then it's continuous. All right, so again, I wanted to show you the 2 steps. You first do the left and the right hand limit to prove there's a limit, and then if there's a limit, you then show what the actual ordered pair is, where the equal sign is. And if those are equal, if the limit is equal to where the ordered pair is, it's continuous. But again, here it's a moot point because it is not continuous. That problem is over. And now let's go to part B. Now, part B is asking for f prime of negative 2 and f prime 3. But I can't find f prime either one of these if I don't have a piecewise function for f prime. So to make a piecewise function, it's actually very easy. You just take the derivative of the top and bottom separately. So I take the derivative of the top, I get 6x plus 2, and I take the derivative on the bottom. Well, the derivative of e to the u is simply e to the u times chain, and the derivative of 2 goes away. And I keep these same pieces here, so 4x and 4x greater than 0. Okay, now that I have these, I'm ready to find f prime negative 2 and f prime 3. So let's start with f prime negative 2. Which one of these equations will include negative 2? Okay, well, I go ahead and look, and x is less than 0. That's negative 2. Negative 2 is less than 0, so I'm going to use this one. So f prime x, we're going to use this one when I plug in a negative 2. And when I plug in a negative 2, I get an answer of negative 12 plus 2, which is negative 10. So I would say f prime negative 2 is negative 10. And for the next one, they want f prime 3. So which piece of that are we going to use? Well, 3 is greater than 0. So we're going to use this one. And now we're going to plug in a 3. So f prime 3 is 2e to the 2 times 3. And of course, that's going to give me 2e to the 6th. And there you go. So that is part B. We've got part A, we've got part B, and now let's go to part C. All right. Part C says find out why, or why does f prime, this is part C, why does f prime 0 not exist? And they're going to mess up a lot of people, because a lot of people are going to say, oh, f prime, I'm going to plug a 0 into both of these where they meet. And this is wrong. They're going to say f prime 0, when I plug it into here, is 2. And when I plug it into here, it's also, e to the 0 is 1, 2 times 1 is 2. And if you were going to do this, you would say, all right, the limit as x approaches 0 from the left-hand side of f prime x is equal to the limit as x approaches 0 from the right-hand side of f prime x, and both of those are 2. And you're thinking, well, it should exist. It's at 2. And that's wrong. Why doesn't it exist? Well, in part A, we learned that it's not continuous. So, I would say in part A, we discovered, wow, I'm writing a book. I don't even know why I'm writing all this stuff. That f of x is not continuous at x equals 0. Therefore, it's not differentiable. Remember, if something is differentiable, that automatically implies that it's continuous. But if something is continuous, it doesn't imply it's differentiable. And not only that, if something is not continuous, so here we found out it was not continuous. If it's not continuous, then it's not differentiable at this point. So, very nice and easy. If something's not continuous, it's automatically not differentiable. We don't even have to check. If something was continuous, then we could check. But it's not. All right, let's go to part D. Oh, by the way, so how would you prove something is differentiable on a piecewise function? You would say it's continuous at x equals a. So first it has to be continuous. And once you've said it's continuous, or you can prove it's continuous, then this is where you go to and the limit as x approaches a from the right-hand side of f prime x is equal to the limit as x approaches a from the left-hand side of f prime x. And that, in fact, if the left and the right-hand limit are equal and it's continuous, then that will give us f prime a. Okay, and the final part, part D. We no longer need this. They state g of x is the integral from -1 to x of f of t dt. And they say find g of 1, which means the area from -1 to 1 of f of t dt. Now, folks, if I want to find the area from -1 to 1, just something to remember, over here on this side we've got some parabola. I don't know what it looks like, but there's a parabola over here. And on the other side, we've got this e to the 2x plus 2 thing going on. And again, actually I know where this hit. This hit at 0, didn't it? All right, whatever. I don't know exactly what it looks like, but on this side we have a parabola, and on the other side we have some other function. And we want to find the area from -1 to 1. Well, to find the area from -1 to 1, you've got to use one of the equations from -1 to 0, and then you've got to use the other equation to find the area from 0 to 1. And notice they're asking you to use t's instead of x's. We should probably do it just to be safe, but it might not matter. So if I want to put a 1 here, I've got to put a 1 here. And to find the area from -1 to 1, it breaks it up at 0. So I'm going to find the integral from -1 to 0. And the equation that I'm going to use is this one. So 3x squared plus 2x dx plus, and again, technically we're supposed to use t's. Let's just hope if you somehow mess this up and you use x's, they're not picky, but you never know. So I'm going to do it right. All right, and then from 0 to 1, we are using this equation. So e to the 2t plus 2 dt. All right, so let's go ahead and find the area under this first piece. Okay, so I take the antiderivative of this, I add one of the exponent and divide, so I get t to the third, and then I divide by 3, I just get this. Here I add one of the exponent, I get t squared, and then divide by 2, this is what I get. And again, I'm plugging in a -1 and a 0. So I plug in a 0, so 0 to the third plus 0 squared minus, and now I'm going to plug in a -1. -1 to the third and -1 squared. Nice, so that's the first piece, top and bottom, plus, and now I need the second piece. So I got to take the antiderivative. The antiderivative of e to the 2t is 1/2 e to the 2t, and the antiderivative of 2 is 2t. Now you might be wondering, Mr. Pygott, how do I know the antiderivative of this has the 1/2 in front? Just a quick reminder, the antiderivative of e to the u du is e to the u plus c. So if I want to know the antiderivative of e to the 2t dt, I would say, all right, to be e to the u, my u would have to be 2t. Therefore, my du would have to be 2 dt. I don't have a 2 dt, so I have to put a 2 offset by a 1/2. And now I have this 1/2 that's in front, and this is now e to the u du. So the antiderivative will have this 1/2 in front, 1/2 e to the u. And of course my u being 2t. So this is what I get, and now I'm going to plug in a 1. Minus, and now I'm going to plug in a 0. And could I simplify this? Yes, but oh, what a lovely country we live in. And this is how I'm going to leave the answer. Just going to leave it, and we're good. Hashtag earn it. Get your points, run away. Have a great day. Thanks for joining me, A, B, and BC students.